Hi students, today I'll be discussing on the question I gave you all yesterday. So this will be the question. So I did a brief drawing here. Before we attempt any questions, what we have to do is always highlight the key points. So for this question, they state that stages, they're talking about the stages. So stages in the enzyme R reaction. Okay, so where is the enzyme R? This will be the enzyme R. Enzyme R. So this is the same enzyme R. Okay, it's a stage, Okay, now we have two types of substrate. So it depends which substrates is compatible with this active site. So this is the active site of the enzyme. So from this shape, you know that substrate Q is more compatible compared to substrate S. Why? Because look at their shape. Are they specific? No, they are not. They are not. So they are not compatible towards enzyme R. Okay. So this hypothesis is known as lock and key hypothesis. In exams they will ask what is this hypothesis. Then you should mention that it is lock and key hypothesis. Okay, first there's three stages. Stage 1, we have enzyme, we have substrate. In stage 2, what can you observe? It is a enzyme substrate complex. Okay, and then once the reaction is done, it will release the blue color thing here is product. So we have enzyme, this is our enzyme, this is our substrate, this is the compatible substrate. This substrate is not allowed to bind with our enzyme because look at their shape. But these substrates are allowed to bind with our enzyme and the reaction will occur. Okay, which is a biochemical reaction, or we call it a metabolism. Okay, there's two types of metabolism. We have the cat and anabolism. So always remember, cat is from complex substance to simple substance, and N from simple substance to complex substance. Okay, we have two, which is cat and N. So catabolism and anabolism. Okay, so let's discuss our question here. Now, every single time for question 1, explain why. So our keyword is why. Enzyme R only. So we're talking about enzyme R. Okay, so where is our enzyme R? This is our enzyme R. This and this, the purple color one. Okay, only act on substrate Q. So which is our substrate Q? This is our substrate Q. So this is the green color part is our substrate Q. So what they're asking is why enzyme R only acts on substrate Q and not, see our key point here, not substrate S. So this is our substrate S. So they're asking why it's not acting with substrate S but only acts with Q. So there's a reason why, because enzyme have specific active site. So look at this active site. This is our active site. So they're very specific and they are only compatible towards certain substrate. Okay, next. So this question they provide us with 2 marks. So we have to give them 2 points. So I'm done with 1 point. What is the another one? So substrate Q has shape that is complement towards or to active site of what? Enzyme R. So this will be our answer. We have 1 and 2. Okay, next, for enzyme R, again this is our second question. Key points is very important. Enzyme R is only required in small quantities. So here this is about the characteristics of enzyme, right? Characteristics of enzyme R only required in small quantities. Why? Because enzymes. So again here we have 2 marks for these questions. 2 marks. Enzyme they are not destroyed, okay, which means they are not destroyed after the reaction or at the end. So right after this process or this reaction, the enzyme remain unchanged. They are not destroyed and they are reusable. They are not destroyed. When they are not destroyed, you can reuse them again. So enzyme, they are not destroyed at end of reaction, and enzyme, they are also reusable. Why? Because they are not destroyed. They can be reusable. And we can give, but they only gave 2 marks here, but if you want to add, it's up to you. Structure remain unchanged. Can you see? Right after the reaction, the product is released, but the enzyme remain unchanged and the structure remains the same. Okay? As for C, we have the excessive intake of citrus fruit. So we have to highlight citrus fruit, it's a citrus food, okay, will affect action of enzyme R on its substrate. Okay, explain why. So from here you should know what is citrus fruit. So citrus fruit or fruit, citrus fruit or food, mostly we call it citrus fruits. Okay, they are acidic. So they are acidic. So citrus fruits or food, they are acidic. Okay, if it's acidic, the pH is low or high? The pH is low. If the pH is low, what will happen to the enzyme? The enzyme is a protein. Okay, if the pH is low, the protein, which is equals enzyme, they will denature. You know what is denature? Denaturing is a process where they become unfold. So when they denature, the active site is no longer complementary to substrate. Okay, so here you have to see citrus food or fruit. Okay, yeah, they say citrus food. Okay, will affect the action of enzyme R on substrate. So enzyme R, and we have substrate here. So we're talking about substrate. It could be any substrate, right? Now we are specifically on Q, substrate Q, which was in green color. Okay, and why? Citrus fruit, they are acidic, When it's acidic, the pH is very low. Okay, what happened to the enzyme when the pH is low? The enzyme is a protein, so they would denature. They would denature. Denature, which means the unfolding occurs. It will go from a solid to something like this. So in this case, the active site is no longer complementary to substrate. So if it's in this structure, there is no active site. There's no active site, and it's difficult for the substrate to come and bind towards the enzyme if enzyme is in this situation. And this yes, so this is the answer. You can write that it is acidic, low pH, the enzyme would denature, and the active site is no longer complementary to substrate. So there's no reaction lah. Okay, thank you from Miss Divya.